Everyone, welcome back to yet another interesting video in our brand new playlist for AP Calculus BC students. So this is the FRQ video solution series by Let's Unbound, where we walk you through each FRQ question from the 2024 AP Calculus BC exam step by step. So in this video, we will solve question number 5. And yes, it's no calculated paper, so there is must-know concept inside this. So watch the video till the end. Yeah. So this is the question number 5. So this is a blend of derivatives, integrals, Euler method, and some full function analysis using table. So yeah, also we will break down each part like interpreting function like motion, approximating values with clear guided explanation. Let's dive into this. First part, a table is given. The function f is twice differentiable for all x with f of 0 equals 0. So this is given initial condition and a table of values x and then f dash of x. Values of f dash, the derivative of f. Yes, f dash means you mean f prime. Okay, values of f prime, the derivative of f are given in the table for selected values of x. For x greater than or equal to 0, the function h is defined by h of x equal 0 to x square root 1 plus f dash of t the whole square dt. Find the value of h dash of pi, that is h prime pi. Show the work that leads to your answer. Easy one. Let's go. This is the fundamental theorem of calculus. So h of x equal to this means h dash of x, like if you differentiate on both sides, h of x will become h prime of x. An integral and the differential, they are opposite, like inverse operations, so they will get cancelled. You will be left with 1 plus f dash of x, the whole square. Simply you apply differentiation on both and you will get this, right? This is by FTA. So now we need to evaluate h prime of pi. So just plug in h prime of pi equal square root 1 plus f prime of pi, the whole square. And let's use the table of values. F prime of pi is this 6, right? So plug in 6, 1 plus 6 square. Simplifying this, you will get 37, under root 37. Perfect. So let's go with the exact answer. H prime of pi is this. That's simple. Part A. Right? Moving to next. What information does 0 to pi integral 1 plus f prime of x the whole square dx provide about the graph of f? So this integral tells something about the graph of f. So what does it say? So this structure, you remember this formula we come across. Integral a to b 1 plus f prime of x the whole square dx. This is nothing but arc length. Okay, so this is arc length structure. So arc length of a graph. So 0 to pi means what? So arc length from x is equal to a to b. This is the formula. So here 0 to pi, that's the difference. So the integrand is all about the same. So integral 0 to pi square root 1 plus f prime of x the whole square dx represents arc length. So of the graph of the function, right? Of the graph f, it's very important. From what? From x is equal to 0 to x is equal to pi. So this is the best and valid interpretation you have to do. Okay, that's simple. Moving to C. Use Euler's method starting at x is equal to 0 with 2 steps of equal size to approximate f of 2 pi. Show the computations that lead to your answer. Yes, Euler's method, we're going to approximate f of 2 pi. All we have is table of values for f prime of x. But we need to approximate for f of something like 2 pi. So this is the Euler's method. This will be a good review and recall for Euler's method. So we are going to use this table also. Starting, the initial condition is very important. So initial condition, it's not directly in the C part. So you go and check the the foremost prime description of the problem. So this is twice differentiable, f of 0. This is the initial condition, so we're going to use this. So use the table, and also we have this f of 0 equal to 0. Right? So now, Euler's method, let's create a tabulation of values. That will be much helpful here. So first column is for x. So put x and then y. Okay, what is y here? F of xi. F of xi means f of x1. So like this is your 1, 2, like that. And then m. M means slope. How can I find the slope? Let me use different color. So f of xi is y. F dash of xi is the slope. And then del x, the step size is important. Del x. Then del y. So change in x, change in y. Del y is m del x plus y. This is the formula. So you need to create 5 columns stating this x, y, m del x, then this final thing. Okay, first what should I start with? Initial condition. This is your x, this is your y. So when x is 0, y is also 0. What is m? F dash of 0. So f dash of 0 I got from the table. Okay, so this m is f dash of your xi is which x you are working under. So I'm working under 0. So f dash of 0, which is equal to 5. Then del x. Okay, what is this del x? That's very important. You can do it at the first. So del x is step size. Del x is the interval that we are working at. We are starting from 0. We wish to approximate till pi, 2 pi. So the difference between them, 2 pi minus 0 divided by number of step size is 2. So del x is 2 pi by 2, which is pi. So that's fixed. It's pi every time. Now let's calculate del y. Del y is m del x. M is pi. Del x is pi plus 0, which is 5 pi. Now this is important. X is, what is the next x? For the next x, you add the del x. 0 to pi, then pi to 2 pi. This is the 2-step size. Step 1, step 2. So what about y? F of pi. But f of pi, no table. This is your next y value. The del y becomes the new y. Okay. Then I need to solve for f dash of pi. The x I am working here is pi. So what is f dash of pi? Let's go here. It's 6. So 6 and del x is going to be the same. And plug in. M del x is 6 pi. And then a plus. What is your y? Y is 5 pi. So roughly 11 pi. Now this 11 pi will come here. That is your f of 2 pi. Approximately, right? This is nothing but f of 2 pi, which is 11 pi. So we don't want to do anything in the third row, like in the last row in every Euler's method. So that's it. We have approximated f of 2 pi is approximately 11 pi. That's simple. Is C part. Moving to part D. Find integral t plus 5 cos t by 4 dt. Show that the work leads to an answer. Okay, we need to integrate this. Of course, it's not that easy straight formula method. It's a product of 2 different functions. So let's use DI method, integrating by parts. I'm sure this method will be very helpful, and yes, it works for every problem, like every integral by parts. So put D and I. So what is your D? Which is easily differentiable. You can pick that. And if a part can become 0 by multiple differentiation, you can pick that. So cos t by 4 is easy to differentiate, but it won't leads to 0. Okay, that's why I'm going to pick d as t plus 5. Then I is the remaining cos t by 4. Okay, and then you have to differentiate this t plus 5 when you integrate, like differentiate, sorry. 5 becomes 0, t becomes 1. 1 when you differentiate, 0. So when you have a 0, you can stop and do the integration for the next step. So this is the formula, cos x by a. So what is cos differentiation? Positive sign. And you put the x by a. then times the coefficient, whichever you got below. So you got 1 by a, reciprocal of it is a. Okay. So this is the differentiation. So sine t by 4 and then 1 by 4 is the coefficient of t. So just multiply 4. Then sine t by 4 is negative cos t by 4 and this 4 is already there. Now times 1 by 4 or like reciprocal of 1 by 4 is 4. Okay, so totally it's 4 times 4, it's 16 and negative here. So I can write it as negative 16 cos t by 4. Okay, cos t by 4 differentiation is negative 4 sine t by 4. Right? So once we got a 0, we will stop. Then what should I do? Yeah, put the integral. So integral t plus 5 cos t over 4 dt equals, and one more thing, for that before di, put plus or minus. So plus, then minus, alternative plus or minus you should put. That sign also which will carry. So then you draw the cross diagonals from left to right downwards. Okay. So you got this. This is equal t plus 5 into positive. So 4t plus 5 sine t by 4. Then negative 16 or negative 1 into negative, it's positive 16 cos t by 4. And that's it. Of course, you need to add the constant of integration because it's indefinite integral. Right? This is the solving part. Right? Using DI method. And yes, so that's the wrap for today's video. So in this question, we did multiple things, starting from calculating h dash of by using Euler's method and then integral solving. So yes, if this video helped, make sure to like, subscribe and keep the following playlist for complete coverage of 2024 FRQs. Yes, if you want to stay connected and join a growing student community, join our official Let's Unbound WhatsApp group using the link in the description below. Thanks for watching. I will see you in the next one. Until then, keep learning and keep practicing.